Hi there, today we're looking at exercise 11G. Now this is looking at our work we've already done on partial fractions and also integration. So there's these two things being combined together to be able to allow us to integrate fractions. And that's what the rational functions means. Rational functions just means you've got basically a function that can be written as a fraction. And that's why the graphic here is all fractions. So first of all, let's consider these two, on the face of it, very, very similar examples. This one is the integral of 8 minus 16x over this thing, 2 plus x minus x squared, and this one's the integral of 8 minus x over this thing. And what's the only difference? The only difference actually is that is missing the 16 there. And yet that 16 makes a big, big difference. This one uses this rule. You should recall this rule. If you integrate a fraction and the bottom of it can be differentiated to give you the top, and it's just log of the bottom. And this kind of is that. So let me just prove that to you. If I differentiate this, so if I write what's the differential d dx of this 2 plus x minus x squared, you get, well, the 2 disappears, the x becomes 1, and the minus gives me minus 2x. That's the answer. Now that's obviously not the bottom. The top rather, but it's actually quite similar to it. Look, this can be factorized as 8 lots of 1 minus 2x. So you can see that this effectively therefore gives me an answer which is the log of the bottom, 2 plus x minus x squared. Oh, it's not quite true because it should be 1 minus 2x. Ours is 8 times bigger than that, so it must be that plus a constant. This one, on the other hand, is not like that. We can't factorize 1 minus 2x into here and get an equivalent expression, and therefore this does not use this rule. But we can still do it, but we have to use partial fractions to do it. That's what I want us to be aware of, that these two very similar looking questions, but two completely different answers. So the first one, as it says, is nearly of that form and can be integrated. The second one is not, and we need to use partial fractions. And I actually give an answer for the first one, which I agree with. I haven't yet done this one. And I suppose if I'm going to do this, I first of all need to know what partial fractions are. Let's see if we can quickly rattle this off. If I write 8 minus x over this, I need to factorize the bottom. So if I factorize the bottom, I get, yeah, I think just looking at it, 1 plus x, 2 minus x. Let's just see if that's right. So I multiply this out, I get 2, yes. I get a minus x plus 2x, that gives me that, and minus x squared. Yeah, so I've done that right. So I can write this as 8 minus x over this double bracket. And because they're both linear, I can write that as a over the first one, should remember all this, plus b over the second one. And you can do the cross multiplication trick. That effectively then gives me a lots of 2 minus x plus b lots of the 1 plus x. And you should recall, we basically then say, well, let's find a number for these things. We could put x equals 2 into it. On the left hand side gives me 6. And 2, because this makes this 0, so all that disappears. 2 plus 1 is 3, is 3b. So b therefore is 2. And if x equals, what do I want? Minus 1 to make that bracket disappear, it gives me 9 equals and 3a. I reckon a is 3. So going back to this, that really is 3. And that really is 2. And I'll just get rid of all that, if I can find where it is. Now this means, of course, that rather than integrating this 8 minus x over this, I'm integrating this instead. So I'm going to integrate this lot. And this is kind of like this now, but you know, it looks slightly different. But because I've got a 3, if I differentiate the bottom, it just gives me 1. So this gives me 3 log of the bottom. Plus, now this one, if I differentiate this, I get minus 1. I've got 2 on the top, so I think it should be minus 2 log of the bottom. You just got to be careful with minuses and make sure you put it in, plus a constant. That's what I think it is. Let's see. That minus 2, so that works. So we've got the answers to these things, and that's what I want us to be able to do. So let's have a look at this question. Let's decide which type it is. x squared plus 6x plus 8, I think this is just a straightforward partial fraction one. I'm going to factorise the bottom, and obviously that gives me, I'm really integrating x plus 2, x plus 4 on the bottom. That's what I want to do between 0 and 1. My very first job, of course, is to find the partial fractions. So perhaps I'll do that over here. 1 over x plus 2, x plus 4 can be written as a over the first one plus b over the second one. And we're going to do this quite a lot, I suspect. So that means that 1 is equivalent to a lots of the x plus 4 plus b lots of x plus 2. And if I set x equal to minus 4, the left hand side is 1, I don't have to worry about that. But minus 4 into this goes minus 2b. And therefore it implies to me that b is minus a half. And when x is minus 2, 1 is equal to, well, that disappears now. Minus 2 goes there, I reckon 2a. So therefore a is a half. So what's that give me? It gives me that this thing, I can just rewrite this, 0 to 1. I'll do it here first, just so we're confident on this. It's 1 over 2 lots of the x plus 2. Minus 1 over 2 lots of x plus 4. Now I could just take that out that as put a half. Both of them a half. So that will get rid of them, both of them that, and effectively I'm putting a half around the outside instead. So it's a half of the integral of 1 over x plus 2 minus 1 over x plus 4 dx. And it's therefore a half of, now if I put this integration into practice now, it's just log of x plus 2 minus the log of x plus 4 between 0 and 1. So I've got to put those numbers in. It's a half of log 3 minus, put 1 into there, log 5 minus, now I put 0 in, I get log 2 minus log 4. And I can probably join these together, and I'll write it here. This is a half of log 3/5 minus log half. I don't think there's much more I can do with that. Let's see what the answer is. Log of 6/5. So let's see what I've done with that. Bear with me. Oh yeah, stupid me. It's a minus in between two logs, so it's quite obvious. It's a half of log, and because it's a minus, it becomes 3/5 divided by a half, and divided by a half is the same as doubling, so that's why it becomes a half of log 6/5. Stupid me there, but that's basically the answer. So that's worked out quite nicely. This next one, it's an integral of this, and I've noticed this as a repeated factor. And you should recall that when it's a repeated factor, we do, let's just write this out again, 16 over x minus 2 squared x plus 2. And when you do this, it's the equivalent of a over the x minus 2 plus b over the x minus 2 squared, that's the bit everyone always gets confused by, plus c over the x plus 2. And of course what I'm meant to now do, therefore, is say, well, 16 there can be written as a lots of. Now we're going to write it over this common denominator over here. At the moment it's got an x minus 2, but a therefore is missing an x minus 2 and an x plus 2. Hopefully you can remember that. The b, on the other hand, it's already got an x minus 2 squared, it's just missing the x plus 2. And the c has got an x plus 2, therefore it's missing the x minus 2 squared. Again, it's easy to see why that goes a bit haywire. Now let's chuck a couple of numbers in. X equals 2. Now x equals 2 means that will go, and that will go. And therefore 16 equals 4b. Or put differently, b equals 4. If I choose x equals minus 2, that one will go, and that one will go. So therefore 16 equals, now if I put minus 2 in here, I get minus 2, which is minus 4. Square is 16. Alright, so that's 16c. I think c is 1. And to get the other one, just pick any number. 0 is as good as any. assuming it works. Sometimes you can get ones which don't work. 16, therefore, if I put 0 into this one, I get minus 2 times plus 2 is minus 4a. If I put 0 into that, plus 2b, if I put 0 into that, I get minus 2 squared, that's like 4c. And of course c is 1, so 4c is just 4. And b is 4, so 2, that's 8. So that's 12. I reckon then, if I move that over, I get 4a equals the 12 minus the 16 is minus 4. I reckon a is minus 1. So at long last, I now think that this thing is equal to a, which is minus 1 over x minus 2, plus b, what was b? 4 over x minus 2 squared, plus c, which was 1 over dx plus 2, dx. Now look, bear in mind that this one and this one are both of this type. They are both of, we're integrating something where the bottom is just x minus 2 and we've got a number on top. So this will become, well, it says x minus 2, so we've got a minus on the top, so it's going to be minus the log of x minus 2. And this last one will become plus the log of x plus 2. Plus a constant, presumably. The bit in the between is the bit which is a bit of a surprise. This can be thought of as 4 lots of x minus 2 to the minus 2. This is basically a backward chain rule. This is what we've seen up till now, where backward, let me write that out, chain rule. We wrote out some things where we said, if you have ax plus b to the power of n, and you integrate it, you basically add a power, and you divide by the power, but you also have to divide by the a as well, the number in front. And so I'm just going to do that. So if I think of it as this, I get, well, it's 4 lots of x minus 2, add a power is minus 1, divide by the minus 1, and I've got 1x, so that's just it. So I think it's minus 4 lots of x minus 2 to the minus 1. Notice this one, because it wasn't to the power 1, it wasn't a logarithm, it was just a basic backward chain rule. Now, what have I done here? I've joined the two logs together, which gives me that, minus 4 over x minus 2, which is that, plus I don't know why I've written k, but it's basically that. Now, there are 3 questions to do. I suppose what I'm looking at on these is what type of questions are they, and then perhaps we might have time to do it, we might not. How are we going to attack these? It's probably best if we leave this for the lesson. I think that would be a nice place to leave it for the lesson, and then we can use that as a starting point for what we are doing in class. And there are answers there for us, but we are going to have a look at exercise 11G in class once we've gone through those 3 examples. I think that's a good place to call it quits, so I hope that works.